Hi guys, welcome to our unit on trig. In our textbook this is going to be found in chapters 11 and 13. So starting off section 11.1, this deals with right triangles. So to kick things off here, let's draw ourselves a right triangle. So we have a 90-degree angle there. And we have sides of A, B, and C. So what should come to mind right away is the Pythagorean theorem, right? A squared plus B squared equals C squared. A and B are the legs, C is the hypotenuse. Okay, we know that. So suppose we were to focus in on a combination of sides and angles in a right triangle. So suppose we call this angle theta. All right, imagine you are standing right here, okay, near that angle theta. Well, if that's the case, then this side is adjacent to where you're standing, or adjacent to where that angle is. This would be our opposite side, and then the longest side is always our hypotenuse. Now from that we have 6 trig ratios that you need to be familiar with. Let's write them down. Alright, so here are the 6 trig ratios. Sine, cosine, and tangent are the 3 main ones that you're required to know. The other ones are born from the 3 original, sine, cosine, and tangent. They're known as the reciprocal trig identities. So let's start with sine. So the sine of our angle is defined as the opposite side divided by the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sometimes we use the phrase so, ka, toa to remember these 3 trig ratios. So cosecant, you have to know this one is paired with sine. This is 1 over sine, so if sine is opposite over hypotenuse, cosecant would be hypotenuse over the opposite. Secant likewise is paired with cosine. Okay, if cosine is adjacent over hypotenuse, secant would be hypotenuse over adjacent, and likewise cotangent is 1 over tan, so that would be the adjacent over the opposite. Okay, let's look at some examples. Oh, and by the way, before we look at some examples, keep in mind a rather popular trig identity. The tangent of theta is equal to the sine of theta divided by the cosine of theta. This is given to you in your IB formula packet. Okay, so that's a popular trig identity to be aware of. And it's easily confirmed by just looking at what we have here for our ratios. Okay, if we were to do the sine 1 divided by the cosine 1, you would end up with just O over A. Okay, now for some examples. Okay, our first example here deals with finding a missing side. Notice this is a right triangle. All right, these trig ratios of sine, cosine, tangent, and the 3 reciprocal ones that we just talked about, this is only applicable in a right triangle. Okay, so make sure you're clear with that. So suppose we're trying to find this missing side. We know this top angle is 34 degrees and this side is 6 centimeters. First of all, you'll be using a calculator for this stuff, so make sure that your mode is set to degree mode. In this unit, we're going to be bouncing back and forth between degrees and eventually radians, but for now, starting off, everything's going to be in degree mode, so make sure you change it. All right, it defaults to radians, so make sure it's in degrees. So if we're standing up top here near this 34-degree angle, this x is an opposite side, this 6 is an adjacent side. That means we're using the tangent, right? So we have the tangent of 34, which is our angle of interest, is equal to our opposite side, which is x, divided by our adjacent, which is 6. If we put this over 1 and cross multiply, we get 6 times the tangent of 34. Go straight to your calculator, and your x is going to be 4.05. Remember 3 sig figs if you're not told how to round. So 4.05 centimeters would be the length of that side. Okay, in our next example here, we're looking at trying to find a missing angle. Okay, up above we were finding a missing side, now a missing angle. So it's still treated the same way. You want to put your little person standing right by the angle you're trying to find. Look at that phenomenal drawing of a person of mine. So this 7 is an adjacent side from where we're standing, and this 9 is a hypotenuse. So in SOHCAHTOA, the one that has an A and an H would be cosine. So let's set this up. So it's the cosine of x. Okay, we're trying to find our angle, which we're calling x. That would equal 7 over 9, because cosine is adjacent over hypotenuse. Now, be careful with your notation here. Write this out correctly. You need to have this down as part of your work. To work backwards and remove that cosine and solve for x, we need inverse cosine. We write that as cos to the negative 1. Okay? So x would equal inverse cosine and then parentheses 7 over 9. It's very important you write down that notation. Okay? You won't get full credit without it. So from there, if you go straight to your calculator, you're going to get 38.9 degrees for this missing angle. Okay? Okay, and by the way, some angle notation, whether we're talking about IB or in your textbook, instead of saying the measure of angle, let's call it P, all right, you might see that, but you may also see P with a little hat over it. Okay, that little hat is a symbol for the measure of that angle P. Okay, so you're used to seeing things like lowercase m, angle symbol, and then m. If you see a letter with a little hat over it, that means the measure of that angle. So just a separate side note, just an FYI. Okay, and finally we're going to look at two special right triangles. The first special right triangle is really an isosceles right triangle where we're going to end up having a 45, 45, 90. Okay, so this is a 45, 45, 90 special right triangle. If this is the case, we know that these base angles are the same. Okay, so they would each have to be 45. Now we know that the sides are in a certain ratio. We know these legs would have to be the same, all right? So we say they're in a ratio of 1 to 1. The hypotenuse here would be 1 times radical 2. You can easily get that by doing Pythagorean theorem, right? 1 squared plus 1 squared, end up getting radical 2 when you solve for that hypotenuse. So how are you ever going to be asked to use this? Well, if you have a situation where we're told, we know somehow this is a 45, 45, 90, and let's suppose we know that this side is 6 and we're asked to find the remaining sides. Well, if they're in a ratio of 1 to 1 to 1 radical 2, it means this other leg would be 6 and this hypotenuse would have to be 6 radical 2. Okay, so that's what it means if they're in a ratio of 1 to 1 to radical 2. Now, you want to use this for things like the sine of 45, the cosine of 45, and the tangent of 45. As you know, you're not always going to be allowed to use a calculator. Now, if this were sine, cosine, tangent of 44 degrees, we couldn't do it without a calculator. But 45 is an angle in this nice special 45, 45, 90 triangle. So you're expected to know how to find things like sine, cosine, and tangent of 45. So looking at our diagram here, this would be 1 over radical 2. The cosine would be 1 over radical 2. The tangent of 45 is a nice clean 1, right? Because it'd be 1 over 1. You have the opposite over the adjacent, okay? So that's the first type of special right triangle. Okay, the second type of special right triangle is when we have a 30, 60, 90. Okay, so these sides are also in a certain ratio. So the 1 across from the 30, we call that 1. The hypotenuse is always going to be that doubled. Okay, so we call that 2. The side across from the 60 is 1 times radical 3. So we can use it in an example where, again, suppose we know that we have a 30, 60, 90 triangle. And let's suppose we know that the hypotenuse is 10. If that's all we know, we could actually find the remaining sides by recognizing that it's a 30, 60, 90 triangle. So we have to go back to these side ratios here. So if the hypotenuse is 10, the 1 across from the 30 we know is going to be half of that side. So this would be 5. The 1 across from the 60, All right, this is going to be 5 times radical 3. Again, go back to your ratios here. Okay, so you can easily find these missing sides by just knowing your ratios. So to take that a step further, you're expected to know how to find things like sine of 30, cosine of 30, tangent of 30, and same thing with 60. Okay, so take a moment, find what these values would be, and go back to your original triangle here. Okay, the sine of 30 is 1/2, right? Remember, opposite over hypotenuse. Cosine of 30 would be radical 3 over 2. The tangent of 30, your opposite over your adjacent, would be 1 over radical 3. Your sine of 60, so now you're going to this top angle. All right, that top angle, so your sine would be radical 3 over 2. Your cosine of 60 would be 1/2. Your tangent of 60, your opposite over your adjacent, would be radical 3 over 1, or just radical 3. So again, if this were 59 degrees or 61 degrees, you could not do it without a calculator. Okay. So finally here, keep in mind what I like to call the big 3 to memorize. Okay, these are the ones that will show up the most often. So you need to know that the sine of 30 is 1/2, the cosine of 60 is 1/2, and the tangent of 45 is 1. These are the ones that are most prevalent and no calculator problems because the values end up being relatively nice numbers. All the other ones have radicals in them. I'm not saying you're never going to see the other ones, but the other ones you don't need to commit to memory necessarily. Okay? Make sure you memorize those big 3. Bye-bye.